This is part 3 of the generic array series and the most difficult part to understand, but hopefully if you understood the toString, you will understand the compare to. Remember or reflect on our problem situation. We are writing a class that is a wrapper class for an array, so we are improving the array structure of Java. So we are replacing a typical Java array with a wrapper class containing the array itself as well. Okay, so we do not know as programmers of this array class which other programs will use it. Will it be cell users? Will it be listings? We don't know. So when we write a program, we have to write it in such a way that it doesn't matter. Most of all, we don't know the attributes of these objects that's going to make use of our class. So this creates a second problem, or sort of a solution as well. So you cannot refer to any attributes of these objects that's make use of our class. You cannot do a toString, you cannot do a deep copy, you cannot do anything with regard to specific attributes or instance variables of the objects in the array. The best strategy is to move the problem back to the class who is using this array. So let me try and re-explain that. So when we did toString, we said we are not worrying how to display these attributes on the screen. We are simply saying the class that wants to make use of it, as for example cell user, must provide a toString. And we will simply use that class's toString. We will call it from our superclass. The same we do with compare to. When we want to compare two objects, let's say we want to sort them, we do not know how to compare them. For example, if cell users are using our program, perhaps we want to compare the outstanding amount, if that is data we have, or perhaps we want to just sort them alphabetically, or perhaps we want to sort them according to their address, or even perhaps according to their cell number. We simply do not know. The only thing is, we know that the users of our fancy class wants to compare different objects. So once again, we relay the program back to the calling class. We say that we can compare your objects as long as you do the comparison. We are only interested in the result of the comparison. We want to say you compare two items. Is the first one bigger than the second one, or is the first one smaller than the second one, or are they equal? On which grounds you compare them is a business matter for the calling class, or the class that's the client class using our array, not for the array itself. Now, this takes a while to understand. I think the best to understand it is a good example. Let's just open the screen a bit up so that you can see more of the program. That will do it. The example we use here is that of the unsorted optimized array. The idea is that fetch has the job to go and search the array for a specific value. If we can do a fetch, if we can see, if we can return a specific object from the array, I think we've solved the compare problem. So once again, first understand what fetch does. It is used by the driver program to search if a specific item is in that array, and it returns the object. So note, T, the target key, is an object, but it has an address, but it's not the address necessarily in the array. It's just the same value, same name. It's the instance variables of the object and be the same. And what is returned is an address, because the name of an object. It will tell you at what address is item stored in this array with the same target key. Now target key is then all the attributes together of the object you are looking for. So if I add John, Pete, Sue to my array, I can say fetch John. And what will I get? I will get the address of where John is stored, so that I can work further with that object in the calling program. I'm not saying fetch me position 300. I'm saying at position 300 I have an object with a name of Pete. I want you to fetch that, I want to search the array, check all the names, and if it's Pete, return the address of that object. This is really complex. We will look at the driver program in a moment, a complete program that will help you to understand this. For the moment, you need to understand that fetch gets an object of type T. It returns an object of type T, which is the item in the current array that has the same value, not the same address. Now, this specific implementation does the fetch with a separate temporary variable node. They have two temps. The second one is used in this part here because part of this fancy fetch method is a bubbling up method. We will talk about that for the moment, but don't worry too much. If you understand, our aim is to understand this line. Yeah, the rest is well explained in your textbook. So the idea is I have an object, a full object, not just a name, a full object T of type T. You can, just to make it more logical for yourself, think of it as a cell user, and I have an array full of objects. Think about it as cell users, and I want to find a specific one. So before we get into the detail, let's first look at the logics. It takes every item, it works with a while, it takes every item, it stores it in a node. Node starts with the first item, then it compares the parameter to the item in that node variable. So node is, if I draw the array we have, each one gets a chance to stand in node. And it takes every time here, it compares whatever is in node. Node started off there at the beginning with the target key. Okay. So, let me just erase all of this now that you understand the role of node. So node is a separate variable, a temporary variable that's going to store each element so that it's easier to compare. I could have said here, instead of node data I dot compare to, but that makes it much harder to read, so I could have said data I dot compare to. That might be easier for you at the moment, but you can see that that line gets too complicated if I do that. But that's what's happening there. It takes data I, and I moves on all the time. Okay. So, in the fetch, it says node compare to target key. And compare to returns basically three things. -1 if the first one is smaller than the second one. Equal to 0 if those two are the same, or larger than 1 or 1 if the second one is larger than the first one. Now I'm referring to two things. You should understand that there's a calling object and a parameter object. Node will be compared to target key. And how will I compare it? I don't know. It depends on compare to. The only thing I'm interested in is the result. If it's unequal to 0, I know those two things are not equal. If that was equal to 0, I know they are equal. but they are not equal to 0, then the while continues, and the while will exit if there are no more items in the list. That would be if I is no longer smaller than next, or if I have found my object that caused that equal sign, equal, to be true. Now, I'm not going to talk about the bubbling up. Fetch for this type of array just moves everything up after it moves every item after the one that was found, one position up. No, I'm lying. Sorry, let me rephrase this. If you fetch an item at a specific place, it swaps it with the person in front of it. So remember our demonstration that if you have a few people standing in a line and I fetch this one, I will move it not to the front, I will simply swap it with the person in front of it. So, and this is done by this code. So that the one I'm using is sort of bubbling up. The one I'm searching for, the idea is that it's quicker to find that one. It is not often done. It's really just to show you that you can make a basic improvement to the array class of Java. And the textbook had to find something to demonstrate this basic improvement. So they came up with a scheme of, if you fetch an element, if you found it, just swap it with its next door neighbor. So this part is really not, to me, that's important to understand. The node that's returned is where you found your last node, when you found that item. Binne!